Hi everyone, Zach here, and welcome to the final lesson for Section 2 of this series on developing a survival game. In this video, we will start our encumbrance system. We'll finish our encumbrance system in Section 3 as part of our equipment system. That said, this series and this video have been brought to you by my Patreon sponsors. And that said, open up your project and let's get started. Hi everyone, and in case I've not been able to edit out the original endings for the last couple of videos, including the bonus video, I apologize. We do have one video left in this section. It was during my review and intro videos I noticed the issue. So we need to make a encumbrance system, and that's the last thing we have to do for our inventory system. To do that, we're going to go to Core, Interfaces, iPlayer Character, and we're going to create a few new events under Stats. So let's create a function. It'll be called Trigger Increase Weight. And we'll have one input of item weight, which is a type of float. All right. We will also have trigger decrease weight. We will rename that so the E is not also capital, which will have also one input of float. We will actually have more related to this, but we'll be doing that in section 3 because we'll have it under our equipment system. And this is item weight again. Both of these will go into our stats category. There we go, and there we go. Next, what we're going to need to do is go over to our player itself. And this is where we'll be doing the bulk of our work. Just make sure to compile. Go to Core, go to Character, go to your player character. We don't need the I get hunger. I'm not sure why that's open, actually. And what we're going to do here on our event graph under our inventory system here. Actually, we'll do it down here and move it when we need to. We're going to create our triggers and a couple of custom events. So we have our trigger increase weight. We have our trigger decrease weight. I'm just going to line those up. And then we have a custom event called, let's get the custom event on screen first, called over Encumbrance Check. All right, so what we're going to do is we are going to take this item float. We're going to do float plus float. We are going to then create a new variable called total carry weight. So promote to variable total carry weight. Like always, we're going to add this in. Now, again, this is not polymorphic, but I am doing it just to make sure. Actually, I'm doing it for multiple reasons. It's honestly, I think it's better not being polymorphic, but if you prefer it being polymorphic, go for it. Just make sure that, you add in negatives when you do decrease if you're going to do this, or if you're using the decrease version of this where this is a minus instead, that for increasing weight, it's positive. We're going to move that to the B pin just in case you do decide to go polymorphic, and total carry goes into the A pin. I also just prefer that. Anyway, we're adding in the new weight to our total carry weight. I'm going to take these nodes, collapse it down to a function. This will be our increase carry weight. And I am going to rename our B pin here, our weight added. And I'm going to put this in the category of stats weight subcategory. Going to do the same for our variable here, stats weight. Next, what we're going to do is then we are going to do our over encumbrance check, which actually we need to add one input here. And this will be weight change. The way our over encumbrance system is going to work, it's not going to be like in Skyrim. By the way, it's going to be float that we're doing. It's not going to be like in Skyrim where you suddenly pick up one flower and you can't move. Actually, that can happen with this too, but the way we're going to do it is for every 10 units over your max carry weight, which we'll have to create a variable for, you will lose a quarter of your movement speed. Again, for every 10 units over, you lose a quarter of your speed. You can change these numbers out to whatever you want, and I'll show you how to do that in a little bit. So we're going to run or do our over encumbrance check. And what we need to do here, I'm going to move this down a bit, is we need to do a float minus a float so we can get the difference between our current carry weight and our max carry weight. So we're going to take our total carry weight here, put that in the A pin. And then for our max carry weight, we're going to promote this to a variable, and this will be max carry weight. So this is how much we can carry before we are considered over encumbered. Going to put this in my stats weight folder. I'm going to compile, and I'm going to give myself a default value of 150. Now you know why the meat cube had to be close to 150. I think I mentioned that earlier anyway. Now, I am going to do the same down here. I'm going to actually duplicate my increased carry weight node. I'm also going to go into my carry weight node in a moment and fix that issue. Decrease carry weight. Let's go into our increase real quick. Line that back up. Line that up a little bit more clearly. Put a return node in. And go back to our decrease now. Line that up. And in this one, what we're going to do is we are going to clamp it so we don't go below 0 somehow. And we are going to clamp this value between 0 and total carry weight, which honestly the total carry weight part is our current total carry weight because we haven't set it yet. And we're going to change this out for a minus. So it's going to be float minus float with this in the B pin. It must be in the B pin due to how math works. Plug that into there, plug that back into there, and do a return node. All right. So this is all stuff you should be familiar with. We've done this all before. Plug that into there, plug the item weight into there. We're going to duplicate this down here. Now, there is a small problem with this, however. If we are decreasing our weight and we're going to do a check here, what we need to do is actually inverse this value. And the way we do that is we move this over a tiny bit and we do a float times float. And we inverse it by making it a negative value. We do that by making this times -1. Plug that into there. And just move this down a bit further. And here we're going to do a branch. All we're going to do on this branch is check if we're over our carry weight. So we're going to do a total carry weight. Is it greater than our max carry weight? Not equal to, just greater than. I mean, if you want to be mean and say at the max you're actually over, go for it. That'll confuse people. We'll engage in good encapsulation and abstraction by collapsing this down to a function. This will be check if over carry weight. It is a pure function. Its return node will be B is over max, as in is over max carry weight. And it will go into our stats weight folder. And I'm going to go in here. I'm happy with how that looks actually. Tuck that under there. And next, what we're going to do is we're going to create a series of events. We're going to do one called set over encumbered. And the way we're going to do this is we're going to take this value and we want to get 40% of our overall movement speed. The way we're going to do that is we are going to do float divided by float. You could do multiply and do times 4 or times 0.4. We're going to divide by 40, however, because it's a little bit clearer that we're losing more than a quarter. We're losing 40% of our movement speed. Oh, okay. So I misspoke earlier. We're losing that instead. All right, so we're losing a 40% instead of a quarter. You can do a quarter by doing 25% or 0.25 if it's multiply. We're going to get our character movement. I don't know why I moved this. We're going to get our character movement. From here, we're going to get our max walk speed. And we are going to... hang on. Item weight change is divided by 40. So that's where we're getting, that's actually where we're making sure that it's X number of units over. We're going to take that result and we are going to multiply that by our max walk speed. So that actually should be a quarter. If our weight change is 10 over, 10 divided by 40 is 0.4. Actually, no, we are losing 40% of our walk speed. So this is how we're determining how much of our walk speed is we're losing, based on how much we're over. Now, what we're going to do with this is we are going to actually switch these nodes around. We're going to put a reroute here. Bring this down a tiny bit. Put a reroute there. Line everything up. From here, we're going to do a float minus float. If I can get this to line up, that'd be lovely. So float minus float. And what we're going to do is we are going to subtract from our total max walk speed there. Please line up. Thank you. From our total max walk speed, this result. So we're finding out what 40% of our max walk speed is for every 10 units we're over. And then we are going to take this value and we are going to clamp it between 0, so we can't go below movement speed of 0, meaning you can actually get really slow, and our default walk speed, which I believe we put under controller, movement, default walk speed. All right, and then we're going to take that, and because we have this default walk speed always set to what our default is on begin play, you know what we can do is we can actually change our max walk speed this way. And we're going to do set max walk speed. There we go. So that we still have our original value of what our default walk speed is. So we won't actually lose that value. Plug that into there. Plug this into the true. And then we are going to disable our ability to sprint. So let's find, oh, hang on. We need to create 2 new booleans to do that. Sorry, I say 2. We're going to do sprint as 1 boolean. So B can sprint. And we'll also do our jump. We'll set this to false, by the way. And the other boolean is B can jump, which we'll also set to false at the end of this. We will move these to our stats, or our bools category. Now, don't skip ahead. Do compile this, because if you don't, you're going to run into an issue. They need to be marked as true by default. All right. Now I'm going to take all of these new nodes we've done, including the reroute there, and I'm going to collapse this to a function called set over encumbered. I don't care if I spelled that wrong. Our input on this will be our weight change. And then we're going to move this to our stats weight. There we go. Tuck that into there. Put a few reroutes in. Make this a little bit easier to read. I'm going to take these and move it to the right. After that, what we need to do is we need to check if the character is already always sprinting. So we're going to do a branch because we need to get them out of a sprint state if they're already sprinting. And is always sprinting. Now, technically, when we set up the final part of this game, you won't be able to move when the menu is open, so this is more just for now, and also to be on the safe side. All right. Then we need to disable our over encumbered. The way we're going to do that is we're going to get our character movement. We are going to set max walk speed. Well, I set max walk speed, and we are going to set it to our default walk speed. That's one of the reasons why we have that default. And then we'll re-enable can sprint as true and can jump as true. We'll collapse this down to a function called disable over encumbered. Again, I'm not too bothered if I spelled that wrong. Stats weight. And the reason for this negative, why we're inversing it, is if we are actually gaining weight back. So if we're dropping weight, we want to actually increase our walk speed instead of decreasing it. If you don't inverse it, what's going to happen is that this is going to return a value, and it's going to go, oh, I'm still over. I should still be losing speed. Whereas with this minus, a negative minus a minus there, that's what's going to end up happening, because this is a negative value, will end up becoming a positive value. So we're going to gain speed back. All right, that takes care of the main part of this. Let's go to our event graph again. Highlight all of this. This is our encumbrance system. Encumbrance system. Let's do a couple of print strings just to make sure this is working. So we're going to do an append here. And we'll do 4 pins, I think. So wait, space, shift enter, movement speed, colon, space. Get our total carry weight. Plug that into there. Not too worried about how this is going to look because we're going to be deleting this in section 3 pretty quickly. And then for the bit down there on our movement speed, let's get our character movement component. Actually, I put this in the wrong spot, but that's fine. We'll get default or get max walk speed and plug that into there. And because I'm not so worried about how this looks, we're going to do this actually before the branch. And that weirdness in how this looks is my note to myself that, hey, we're going to delete this because that doesn't match my style, as you know. This is only for debugging purposes. Let's go over to our sprint and jump system. So let's find our jumps, which are right up here. As I mentioned, we're going to need some room. So we're going to put a space there. Bring a reroute with that. And let's go this way. So some of you this way too. And you. We are going to put a branch in here. And we're going to check can jump. There we go. So if we can jump, let's make sure that we can jump real quick. That is working. Awesome. We're going to go down to our sprint system. And our sprint system, well, we already have part of this set up. Remember I said, hey, we're going to have something else in here. That's why we have that marked as true already. We're going to add in our can sprint. Likewise, down here, we're going to move this way. We're going to grab these nodes. We're going to expand this out. We're going to move this over a little bit. We're going to do another branch here. And in this branch, we'll do the same check of can sprint. Let's make sure that we can still sprint, by the way. Otherwise, something is wrong with that setting. I'm walking. I'm holding shift. I hit caps lock. I release caps lock. Our sprint system still works. Next, what we need to do is we need to go to our inventory system. In our inventory system, every time, hi, I'm glad I have AddItemMaster open. That's where we're going to start. We're going to look for these encumbrance system checks. So in our AddItemMaster, under our in our BP inventory AddItemMaster, we're going to get player character. We are going to expand this comment before I forget to do so, because things get weird if we don't in terms of actually lining crap up. And we are going to trigger weight increase. We're going to plug that into that branch there. And this is the easiest of all of them, to be fair. What we're going to do is we're going to do a float times int. The int in this case will be 1 because we're only adding 1 item. That's our set amount here, actually. If you want to, you could do your... Actually, you shouldn't do your amount local for this one. For our value at the bottom here, what we're going to do is we are going to get our index local. We are going to get our inventory slots data. Notice that one of them is in the comment, one isn't. We're going to get a copy at this index. We are going to then... I'm going to just break this, honestly. Split pin structure. Get class defaults. And from our defaults, we're going to get item details. We're going to break those. We're going to hide unconnected pins here. And from our item details, what we're going to do is get our item weight. So we have item weight, and that's our float. Hide unconnected pins. And there we go. Now, again, good encapsulation. We're going to take these, collapse them down to a function of get item weight. This will be our index ref. This will be item weight. It will be a pure function, and it will be stored in utility functions because it relates to our utilities. There we go. All right, that one was pretty simple. We have our single item weight event. As for our stack items, so AddToStack, we have this nice, lovely little branch of things that we need to do. I'm going to cheat a tiny bit, and I'm going to copy these nodes because this is the base of everything we need. Let's start at our top where we're adding an item to an existing stack. So here, what we need to do is make that comment a little bit bigger because we have some maths to do, is we aren't adding in one item. We aren't adding in an amount. We need to account for an amount, however, already existing as well. So we can't just take the stack amount and add it in as our total here, is what I'm saying. We have to take what's already in that stack and add it in as well. Actually, no, I'm thinking about later on. Here, because we're adding to a stack and not creating a stack or not having multiple stacks, we can literally just take our amount local and plug it in. That was the easy of them. All right, for this one down here, it is a bit more complex. Sorry about that. I was getting my order of events wrong. So for this one, we can't just plug a number in. In fact, actually what we need to do is we need to break this, and we need to consider, are we adding it to an existing stack or a non-existing stack? So we're going to do a select node, and our selector is if it's an existing stack or not. If it is not an existing stack, well, first off, let's duplicate these over here. This one is really easy. We are taking the max stack amount because we've reached the max stack. So max stack size local. If it is an existing one, or sorry, if the stack is existing, then we're using that temp amount, even though that temp amount is our amount local. So temp amount local goes in here. And that's accounting for the difference between what's already in the stack, what we're trying to pick up, and if we're going over our max. And finally, let's copy these nodes yet again. Actually, I'm going to copy these nodes. Actually, I'm going to copy all of these nodes because it is literally the same down here. This was the easier of them. Or the easier two, or the top and bottom ones. All right, now what we need to do is consider other times we lose item weight. Discard. Now we have two events in here that we have to do for our discard. So the first thing we need to do is actually get our item weight. That's what this is about. So we want to get our item weight. Why do we want to get our item weight early? Well, we're destroying the item potentially. We're getting rid of that information of how much is in the stack. We don't have that information to pass over here. So we're going to store the information before we get rid of the information from the original source, that is. So I'm going to do my get item weight. I am going to do it at the index local. And I am going to create a temporary holding variable called weight local. Going to just plug that in there. And again, all we're doing is, I'm also going to move this to the right so I can make the comment a bit bigger. So our encumbrance, store weight of item to be discarded. Because we're discarding it, we're not going to have that information, but we still need to trigger a weight decrease on a successful discarding of an item, be it the item was used or be it the item was dropped. Because, hey, we should still be losing weight. And what we're going to do is get player character trigger decrease weight. All right. don't do what I just did there. Grab the pin, not the node. Plug that into there. Plug that into there. And for item weight, it is a float times integer. The integer is our amount local, the amount we're discarding. Our float is the weight local. So all we're doing here is actually removing the weight. So this removes weight from player. All right, I believe that covers everything we need to do outside of testing it. Any other time we use these nodes will be in relation to the equipment system. So let's go make sure this works. Let's pick up this cube. I now have a weight of, oh, okay, why did the cube weigh so? Oh, there's 2 of them. Let's get rid of 2 of them. All right, let me just pick up 1. Well, our encumbrance system didn't go off, but that's because I have a weight of 140. That should be 148. And now I have 152. And notice my speed has dropped. Notice my speed continues to drop. I can't sprint anymore. I can't jump. My speed continues to drop. $177. Let me drop the meat cube. Let me eat the meat cube, actually. And notice I can sprint again. Let me pick this meat cube up. I have a weight of 177. And I am moving at a very sluggish rate. Weight of 200. So 25, 50, 75, 80, 140. 140 plus 80 is 220, question mark? But technically I'm still moving. I just am moving so slowly that the character actually can't move. But that is our encumbrance system. And now for reals, we are done with section 2 of this tutorial. If you've enjoyed working on this, your inventory system, being able to pick up multiple items, being able to discard items, split stacks, have an encumbrance system that is a little bit more dynamic than you just gone over your max weight, then make sure to hit the like button to let me know that I'm bringing you content that you appreciate and enjoy. If you've enjoyed setting up all of this and you want to be here when we do, say, our equipment system, make sure to hit that subscribe and notify icon. This series has been brought to you by my Patreon sponsors like Rian, Haynes, and Quad Menson. If you want a copy of this project, consider supporting this channel and on Patreon, and supporters at higher tiers will get instant access to any ongoing project. Supporters at other tiers will get access to projects once the series has completed on YouTube. All of that said, I look forward to seeing you in Section 3. And again, for real, congratulations on getting through Section 2. And I hope that you have a wonderful day.